Picture this. You buy a smart thermostat for your home. You install it, connect it to Wi-Fi, and it works great. You can adjust the temperature from your phone. It learns your schedule. Everything is fine. Until one day, that thermostat becomes part of a botnet that attacks a hospital's network halfway across the world. Sound dramatic? It's not. This has happened. The Mirai botnet in 2016 took down major parts of the internet using nothing but hacked cameras and routers. And the reason those devices were vulnerable is simple. They were never built to be secure in the first place. Here's the thing about most IoT devices. They have tiny computers inside, small microcontrollers that handle one or two tasks. But historically, these chips were designed for things like microwave ovens and washing machines, things that don't connect to the internet. So manufacturers optimized for cost and power consumption, not security. Then the Internet of Things happened. Suddenly, all those cheap, simple chips needed to connect to the internet. And manufacturers did what manufacturers do. They added a Wi-Fi module and called it a day. No secure boot, no hardware root of trust. No update mechanism. Once a device shipped, that was it. If a vulnerability was found 6 months later, there was no way to patch it. The device was stuck with whatever bugs it shipped with. And these devices stay in the field for years. A factory sensor might run for a decade. A smart meter might sit on the side of a building for 15 years. That's a long time for a vulnerable device to be connected to the internet. The consequences are real. Botnets that launch massive attacks, data breaches that expose personal information, compromised networks that give attackers a foothold inside companies. All because nobody thought about security when the chip was designed. So Microsoft looked at this problem and decided to build something from the ground up. Not a software patch, not a security service you bolt on later. Something that starts with the silicon itself. What Azure Sphere actually is. The big picture. Azure Sphere is Microsoft's end-to-end IoT security platform. That sounds like marketing speak, so let me translate it into plain English. It's three things working together: a certified microcontroller chip, a secured operating system, and a cloud security service. You need all three. Take any one away and the whole thing falls apart. The key phrase you'll hear a lot is security from silicon to cloud. That's not just a tagline. It means the security starts at the physical chip level and extends all the way up to the cloud service that manages the devices. Every layer is designed to work together. Now contrast that with the old approach. Most IoT security is bolt-on. You take a regular chip, run a regular operating system, and then try to add security features later. Maybe you encrypt some data, maybe you add a password. It's like building a house with paper walls and then installing a fancy deadbolt. The deadbolt works, but someone can still walk through the wall. Azure Sphere takes a different approach. Security is built in from the start, not added later. The chip itself has security features baked into the silicon. The operating system is designed specifically to run securely. The cloud service manages the whole fleet. Here's an analogy that helps. Think of it like a secured building. The chip is the reinforced door. It's strong at the entry point. The operating system is the security guard inside. It makes sure people only go where they're allowed. And the cloud security service is the central monitoring station. It watches everything, sends updates, and responds to problems. Now, a common question, is Azure Sphere just another IoT platform? Not really. Most IoT platforms like AWS IoT Core or Azure IoT Hub are about connecting devices to the cloud and managing data. Azure Sphere is specifically about device-level security. It's the foundation that secure IoT devices can be built on. Think of it this way. AWS IoT is like a postal service. It moves your data from point A to point B securely. Azure Sphere is like building a vault for your data before you even hand it to the postal service. They solve different problems, and you could actually use both together. So what makes the chip so special? Let's break down each layer, starting with the silicon itself. Layer 1. The silicon, the Azure Sphere MCU. Let's start with the chip itself, because that's where everything begins. The hardware foundation of Azure Sphere is a custom-designed microcontroller. Right now, the main chip you'll find in production is the MediaTek MT362. Now, on the surface, it looks like any other microcontroller. It's small, it's relatively low power, and it handles basic processing tasks. But what makes it different is what's built into the silicon. Inside this chip, there's something called the Pluton security subsystem. Pluton is not software. It's a separate, dedicated security processor built directly into the hardware. Think of it as a tiny, tamper-proof computer inside the main computer. Its only job is to handle security operations. Why does that matter? Because it creates something called a hardware root of trust. Here's what that means in plain English. When the device powers on, the Pluton subsystem is the first thing that starts running. It checks its own identity at the lowest possible level, the silicon itself. Before any software loads, before the operating system boots, before anything else happens, the chip can verify that it is who it says it is. This is fundamentally different from software-based security. With software, you're always trusting that nothing has been tampered with before the security software loaded. But if someone modified the bootloader or the firmware, your security software might be checking the wrong thing. Hardware-based trust doesn't have that problem. You can't modify Pluton without physically accessing the chip, and even then, it's designed to resist tampering. From there, the chip enforces secure boot. The device will only run software that's been cryptographically signed and approved. If someone tries to load unauthorized firmware, the chip simply refuses. It won't boot, it won't run. The device stays locked. The MT362 also has a crossover design. It combines real-time processing, the kind you need for controlling motors or reading sensors, with application processing for more complex tasks. That means a single chip can handle both the low-level control and the higher-level connectivity and security. No need for two separate processes. Now, why does hardware security matter so much? Because software security can be bypassed. A clever attacker can find bugs in the operating system, exploit vulnerabilities in applications, or trick the software into doing things it shouldn't. But hardware security is much harder to crack. You'd need physical access to the chip, specialized equipment, and a lot of time and skill. Here's the analogy that sticks. The Pluton security subsystem is like a tamper-proof safe embedded in the foundation of a building. You can't move it. You can't open it without the right tools. And even if someone breaks in through a window, the safe is still secure. That's the level of protection we're talking about. But hardware alone isn't enough. The operating system running on top is just as important. Layer 2, the OS, a locked-down Linux. So you've got this secure chip. What runs on it? A custom, locked-down, Linux-based operating system built specifically for Azure Sphere. Now, when I say Linux, you might think of Ubuntu or Debian, a general-purpose operating system you can install on a laptop or a server. Azure Sphere's OS is nothing like that. It's been stripped down to the bare minimum. Every feature that isn't absolutely necessary has been removed. No web server, no desktop environment, no unnecessary drivers, just the core components needed to run secured applications and communicate with the cloud. Why does that matter? Because every line of code is a potential vulnerability. The more code you have, the more bugs you can have. By keeping the operating system small, Microsoft reduces what security researchers call the trusted computing base, the amount of code that must be trusted for the system to be secure. Fewer lines of code means fewer places for attackers to hide. But it's not just about removing features. The OS also enforces something called dynamic compartmentalization. That's a fancy term for a simple idea. Applications are isolated from each other. If one app gets compromised, it can't affect other apps running on the same device. Each application runs in its own sandbox with its own memory space and its own permissions. The OS also controls hardware access through opt-in peripheral use. An application can only use hardware components it's been explicitly allowed to access. If an app tries to read from a sensor it doesn't have permission for, the OS blocks it. Period. No exceptions. This prevents a compromised app from accessing things it shouldn't. Now here's the part that's different from most IoT operating systems. Microsoft manages and updates the OS, not the device manufacturer. When Microsoft finds a security vulnerability, they release a patch. That patch gets pushed directly to devices through the Azure Sphere security service. The manufacturer doesn't have to do anything. They don't have to test it. They don't have to approve it. Microsoft handles the entire update pipeline. This is a huge deal. In the traditional IoT world, when a vulnerability is found, the manufacturer has to develop a fix, test it, get it approved, and then somehow get it onto devices that might be scattered across the globe. That process can take months, if it happens at all. With Azure Sphere, the update happens automatically, often within days of a vulnerability being discovered. Why does the OS approach matter so much? Because most IoT breaches happen at the software layer. Attackers don't usually try to crack the hardware. That's too difficult. They look for software bugs, they find unpatched vulnerabilities, they exploit weak access controls. By locking down the OS, reducing the attack surface, and automating updates, Azure Sphere removes the most common attack paths, so you've got secure hardware running a lockdown OS. But how do you manage thousands of these devices in the real world? That's where the cloud service comes in. Layer 3, the cloud, the Azure Sphere security service. So you've got this secure chip with a hardware root of trust. You've got a lockdown operating system that isolates applications and controls hardware access. But here's the thing, a device that's secure on day one isn't necessarily secure on day 1000. Security isn't a one-time setup, it's an ongoing process. That's where the cloud service comes in. The Azure Sphere security service is the command center for the entire fleet of devices. Every Azure Sphere device connects to this service throughout its life. And this connection isn't optional, it's mandatory. A device that can't reach the security service won't work properly. That sounds harsh, but it's intentional. It ensures every device is always managed, always monitored, and always up to date. Let me walk you through what this service actually does. First, certificate-based authentication. Every Azure Sphere device ships with a unique, verifiable identity baked into the hardware. When the device boots up and connects to the cloud, it presents this identity. The security service checks that the identity is valid, that the device belongs to the right tenant, and that it hasn't been tampered with. If anything looks wrong, the service can block the device from connecting. This is fundamentally different from the old model where devices used simple passwords or shared keys. If a password gets stolen, you have to change it on every device. With certificate-based authentication, each device has its own unique credential. Compromising one device doesn't compromise the rest of the fleet. Second, automatic over-the-air updates. This is the killer feature. When Microsoft finds a security vulnerability in the Azure Sphere OS, They develop a patch and push it directly to every device through the security service. The device downloads the update, verifies it's signed by Microsoft using the hardware root of trust, and installs it. No waiting for the manufacturer to develop a fix. No waiting for IT teams to schedule maintenance windows. No devices that never get updated because nobody remembers to check. The update happens automatically, often within days of a vulnerability being discovered. Now, here's something important. The device can't refuse an update. If the security service says an update is available, the device has to install it. Again, this sounds controlling. But in the world of IoT security, it's necessary. The Mirai botnet happened because devices were shipped with known vulnerabilities and nobody ever patched them. Mandatory updates prevent that scenario. Third, failure reporting. When something goes wrong on an Azure Sphere device, a crash, a security event, a hardware fault, the device reports it back to the security service. This gives manufacturers and operators real-time visibility into the health of their entire fleet. If one device starts behaving strangely, you know about it immediately. If a pattern emerges across multiple devices, you can investigate and respond. Fourth, remote monitoring and attestation. The security service can check that every device in your fleet is still running trusted software. It can verify that the boot process was clean, that the OS hasn't been modified, and that the applications are the ones you approved. If a device fails this check, the service can flag it for investigation or block it from accessing your resources. And finally, the 10-year support commitment. Microsoft has committed to supporting Azure Sphere devices for a decade. That means security updates, OS patches, and cloud service availability for at least 10 years from when a device is deployed. For industrial equipment and infrastructure that stays in the field for years, that's a huge deal. Here's the analogy. The security service is like a central monitoring station that watches every door in a building in real time. It knows who came in, when they came in, and whether they're supposed to be there. If a door gets damaged, the station sends someone to fix it immediately, and every few months it upgrades the locks on every door without anyone having to ask. Now let's put all three layers together and see how they actually work as one system. How it all works together, the real power. Let me walk you through a realistic scenario. Imagine a company builds a new industrial sensor, something that monitors temperature and vibration on a factory production line. This sensor uses Azure Sphere. Let's follow what happens from the moment it's powered on for the first time. Step 1. The chip boots. Remember the Pluton security subsystem? It's the first thing that starts running. It checks its own identity at the hardware level. Then it verifies that the bootloader is signed and approved by Microsoft. Only then does it allow the bootloader to run. If someone had tried to flash unauthorized firmware onto the chip, the boot process would stop right here. Step 2. The bootloader loads the operating system, but it doesn't just load whatever is stored in memory. It verifies the OS image against a cryptographic signature. The OS must be in a known good state signed by Microsoft and not tampered with. If the OS has been modified, the chip refuses to load it. The device stays locked. Step 3. The OS boots up, and the device reaches out to the Azure Sphere security service. It presents its unique certificate-based identity. The service checks that this device belongs to the right tenant and that its identity is valid. If everything checks out, the device is authenticated. Step 4. The security service checks the device's software version. Is it running the latest OS? Are there any security patches that need to be applied? If updates are available, the service pushes them immediately. The device downloads the updates, verifies they're signed, and installs them. Only after the device is fully up to date does it proceed to the next step. Step 5. The device starts working. It begins sending telemetry data, temperature readings, vibration levels, operational status, back to the cloud. All of this communication happens over authenticated, encrypted channels. The device also starts receiving commands if needed, maybe a configuration change or a request to run a diagnostic. Every command is verified and authorized. Now here's what happens throughout the device's life. Every few weeks or months, Microsoft releases security updates. The Azure Sphere security service pushes these updates to the device automatically. The device installs them, often without any downtime. The factory operator doesn't have to do anything. The sensor just keeps working, but it's always running the latest, most secure software. If something goes wrong, say the device crashes or detects an anomaly, it reports the failure back to the security service. The operator gets an alert. They can investigate remotely. If needed, they can push a fix or reconfigure the device, all without sending a technician to the factory floor. The key insight here is something that's worth repeating. Security isn't a feature you add to a device. It's the foundation everything runs on. Azure Sphere doesn't bolt security on after the fact. It builds the entire device, hardware, OS, and cloud management, around security from the start. That's the real power of the platform. Not any single feature, but how all three layers work together. The chip provides the hardware root of trust. The OS provides the locked down environment. The cloud service provides the ongoing management and updates. Together, they create something that's greater than the sum of its parts. But a security platform is only as good as its track record. So let's talk honestly about the vulnerabilities that have been found. The honest picture, vulnerabilities and reality. Let's be honest. A platform that promises bulletproof security is going to attract scrutiny. And Azure Sphere has had its share of it. In 2002, Microsoft launched the Azure Sphere Security Research Challenge. They invited security researchers to poke at the platform, find weaknesses, and report them. Cisco Talos took them up on it. Over time, they found 31 vulnerabilities across the stack. What kind of bugs? Kernel issues that could let an attacker crash the system. Privilege escalation paths that would let a malicious app gain higher-level access. Unsigned code execution, the kind of bug that undermines the only signed software runs promise. Some of these were serious, a few were rated critical. Now, here's the important context. Microsoft invited this research. They set up a formal program, paid researchers, and fixed every single vulnerability that was reported. Every one of those 31 bugs was patched through the automatic update system we talked about earlier. Within weeks of discovery, the fixes were pushed to devices in the field. And here's the other thing. There are no documented cases of these vulnerabilities being exploited in the real world. No large-scale attacks, no botnets built from Azure Sphere devices. The research was thorough, but it was also contained. That doesn't mean Azure Sphere is perfect. No platform is. What matters is how quickly issues are found and fixed. And on that front, Azure Sphere has a strong track record. The mandatory update pipeline means that when a vulnerability is discovered, every device gets patched. Not some devices, not devices whose manufacturer bothered to release an update. Every single device. Compare that to the rest of the IoT world. Other platforms have vulnerabilities too, but many of them lack a mandatory update mechanism. A vulnerability gets discovered, the manufacturer releases a patch, and then nothing. Devices sit unpatched for years because nobody pushes the update. Azure Sphere removes that problem. The trade-off is real though. A tightly integrated platform means strong security guarantees, but it also means dependency on Microsoft. You can't swap out the OS, you can't use a different chip. You're all in on the Azure Sphere ecosystem. For some organizations, that's a deal breaker. For others, it's a fair price for not having to manage security yourself. The honest takeaway is this: Azure Sphere isn't invulnerable. It's had bugs, it will have more bugs, but the platform is designed to handle that reality. The update pipeline, the hardware root of trust, the lockdown OS, all of it exists because Microsoft knew that vulnerabilities would be found. The goal isn't to be perfect, it's to be resilient. So who is this actually for? And when should you care about it? Who is this for? Real-world use cases. Azure Sphere isn't for every device. It's for devices where a security breach would cost more than the device itself. Think about industrial sensors that monitor factory equipment. A compromised sensor could send false readings, causing operators to make bad decisions. Or worse, an attacker could use that sensor as a foothold to move deeper into the factory network. The cost of that breach could be millions in lost production. Think about commercial appliances, vending machines, HVAC systems, building automation controllers. These devices sit in public spaces, connected to networks, often for years. Nobody updates them. Nobody thinks about them. They're perfect targets for attackers looking for an entry point. Think about smart city infrastructure, traffic lights, environmental sensors, water system controllers. If these get compromised, it's not just data at risk, it's physical safety. And think about healthcare devices, equipment that needs long-term security compliance, devices that can't be easily reached for manual updates. The kind of equipment where a security breach could literally be a matter of life and death. What do all these have in common? Devices that need to be in the field for years. Devices that can't be manually updated. Devices where a compromise would cause real damage. What Azure Sphere is not for is hobby projects or simple home gadgets. If you're building a smart light bulb that costs $20, Azure Sphere is overkill. The chip alone costs more than the entire product. And if that light bulb gets hacked, the worst that happens is someone turns your lights on and off. The deciding question for any device maker is simple. Is this device something where a security breach would cost more than the device itself? If the answer is yes, Azure Sphere is worth looking at. So that's Azure Sphere, Microsoft's most ambitious attempt to fix IoT security by starting at the chip level and owning the entire chain from silicon to cloud. If you're building connected products or just want to understand where IoT security is headed, this is the platform to watch. Subscribe on your favorite podcast platform and share this with someone building connected products.